Alright, so let's look at the formula to take our integral. Because your homework is all in terms of velocity and position, I'll try to keep with that same format. Okay, so real quick, we remember that dx dt is the slope of a position time graph gives us velocity. So if we take this and manipulate it so that dx is equal to v times dt, and we take the integral, this infinite sum of all those little v values times the dt, v values times the dt, just finding each of those little areas underneath there. If we add up all those v times dt's, where dt is just a very small change in time, we would end up adding up all the areas, giving us the position. So this is saying sum up all the small areas to get the total area, sum up all the small v's times the dt's, and then that would equal your total position. Okay? So what you'll be given is like a velocity function. V is equal to 2t squared minus t plus 1. Okay? So similar to a derivative, we would have a specific type of formula here. So for going from velocity to position, we would have to have some constant times t to the nth power. Okay? Now if we take the integral of that with respect to t, that's going to equal, what we're going to do is we're going to take the power, we're going to add 1 to it. And once we do that, we have to divide this by n plus 1. So if there's a constant there, it's the constant on top divided by whatever the power is plus 1. Okay? Then we multiply it by t to the n plus 1. So similar to how the derivative had an n minus 1, doing the opposite, we're going to add a power. Let's see if we can follow that in this example problem here. So here we want to take the integral of velocity. So we know that the integral of velocity as a function of time is going to give us position. So our position is going to be, so we have our constant, which is 2, divided by, we have t to the 2, so it's got to be divided by 2 plus 1, times t to the 2 plus 1. Okay. Minus 1 divided by 1 plus 1 is 2, times t to the n plus 1. So basically the power and what you're dividing by is exactly the same. Alright? So here we go, t to the 0. So we have to do 1 divided by t plus 1, which is 1. So that's plus times t, 1 times t to the first. So if you notice, the t squared becomes t cubed, the t becomes t squared, and the 0 becomes t to the 1. Okay, and it's all from that same formula. It's very similar to the derivative. Okay, so let's take a look at another one. So let's write this out again. So if we have the integral, the addition, the infinite sum of c times t to the nth power times dt, okay, what we're going to end up with is that constant divided by n plus 1 times t to the n plus 1. Okay, so if we have v equal to 3 minus 4t, and let's write another one out over here. V is equal to 3 plus 5t minus 6t squared. Okay. So here we have a constant times t to the 0. So we have to add 1 to 0, so t to the n plus 1, so it's 1, so it's 3 divided by 1. So the position is going to be 3 divided by 1 times t to the 0 plus 1, which is 1, minus, here we go again, t to the 1, so we have 4 divided by t to the 1 plus 1 is 2, so it's 4 divided by 2 is 2, t to the 2. There's our position. Okay, let's look over here again. 3t, okay, position is 3t plus, so that's going to be turned t squared, and we have to divide that, so it's 5 divided by 2, t squared. This is going to turn to t3, okay, minus 6 divided by 3, which is 2, t cubed. All right. Let's try a couple more. Let's go from the acceleration. So let's say the acceleration is negative 9.8. Okay. Or we can have a changing velocity. So let's make it, I don't know, just something strange, 5t. All right. So negative 9.8. If we wanted to figure out what the velocity is going to be at any period of time. So this is negative 9.8 times t to the 0, which is 1. So we're going to have t to the 1. So this is going to be negative 9.8 divided by 1 times t. All right. Now, to write this in perspective, this is the final velocity. So this is actually final velocity equals some initial velocity, we're going to assume it's 0, plus a times t. Okay? So final velocity equals some initial velocity plus a times t. Do this again. The position is going to be negative 9.8 divided by 2, which is 4.9, t squared. All right, and again, in calculus, you're going to see that every time you take an integral, there's going to be plus some constant. Okay, we aren't going to deal with that constant in the physics portion, but this is where that constant comes into place. This is plus some other constant as well. And what this equation would turn into is, if we, first of all, the integral of v is x, integral of that is, with respect to time, is v times t, plus, and you can see here what happens is that's 1/2 of a. So that's going to be t squared divided by 2. So that's going to be 1/2 a t squared. So you can see that the integral can be done with an equation, not only with number. Okay, we will do more of this after you've figured out how to do the number. All right, same thing with this. So see if you can figure out what the velocity is going to be. Make sure you're following your equation, and at this time, if you're not understanding how to use this equation to convert this, I'm hoping that you send me an email. Alright, so you have to add 1 to the exponent, so that's t to the 1 is t to the 2, so it's 5 divided by 2, t to the 2. And then for the next one, that's going to change to 3, so that's going to be 5 divided by 2 times 3, which is 6, t to the cubed. Okay, so there is the application of the derivative. We'll get more involved with the major understanding of the integral, not just being able to complete them with a number, similar to your summer assignment when we come back. And the integral is going to be used throughout the entire year, and it gets very involved towards the end of the year. If you take a look at your equation sheet, you can see that the integrals and derivatives, it looks a little fuzzy, are used throughout the year, but they get a little bit more involved towards the very end of E&M. Okay, and hopefully you're taking AP Calculus at the same time, so this stuff should end up being a little bit easier when you get to that. Okay, so that's the basic understanding of an integral and a derivative that you're going to really need to know and be able to apply very soon after coming back from break. So hopefully these videos worked out pretty well for you, and please make sure you're sending me emails, asking a lot of questions. If I have to try to answer you in video form, I'll make sure I send it out through your Google accounts.